But before we get started, I just need to go over a couple of things. First, you'll notice that we've asked you to turn off your video and your mics as well. This is just to protect everyone's privacy. So while we can't see or hear you, we can still communicate with us through the chat. So there's a chat button in the same area where the thumbs up and the claps are. So during the workshop, if you have any questions or problems, please type them into the chat, and Andrea, who's our moderator, she will help to answer your questions. And lastly, I want you guys to have fun. I encourage you to ask questions and interact with us. You can post claps or thumbs up whenever you hear or see something that you like. We want it to be fun for everybody. So, all right, so we're ready? You gonna give another thumbs up from everybody? Okay, let's go. So here are Jess and Gav, the authors of Ava In Codeland. Over to you guys.
Hi everyone. Okay, I'm just sharing my screen so you can see the book. Could I get a little thumbs up if you're all seeing this? Amazing. Okay, so this is Ava In Codeland. It was written by me and Gav, who's here as well, doing sound effects. And it was illustrated by Layra Martin, who's amazing, as you'll see. So, Ava thought living in a computer game was pretty great. If she didn't like something, she could just change it. Moon size equals large, sky color equals purple, cupcakes count equals 1,762. But her favourite part was spending time with her best friend Pixels, even if he did have a habit of turning into the things he was scared of, like jellyfish,
Help!
broccoli,
Eee!
and stripy underpants.
No!
Ava spent every day coding her world exactly the way she wanted it.
Level 1, breakfast roller coaster. Level 2, underwater disco. Level 3, birthday every day.
But not everything was perfect. Max Haxalot was the game's baddie, and he was a big, piratey cheat. When Max got bored, he rode around the game on his magical pirate unicorn, breaking bits of Ava's code. One time, Max turned the polar bears green, which made them feel very silly. One time, he gave the octopuses 36 arms, so they got into a terrible tangle. And one time, he swapped the sound files, so the dog said tweet and the birds said woof.
Woof, woof, tweet, tweet, woof, woof, woof.
So every time, Ava had to find the broken piece of code and fix it. Polar bear color equals white.
Phew!
Octopus arms equals 8.
Yay!
Bird sound equals bird.m4a.
Tweet, tweet.
Wait, what?
Mm.
But one day, Max Haxalot went too far. Ava woke up to find everything around her was black. Max had really messed up her code this time, and now she was trapped in the game over screen with nothing but a really cute, sad panda. Ava slumped down against the giant G. All her hard work was lost, and there was no way she was starting again from the beginning. But then she heard squares chattering, and she couldn't see Pixels anywhere. Where are you, Pixels?
I don't know.
Pixels was so afraid of the dark that all of his colours had switched off. So Ava began doing what she did best, coding. She started with some lights so she could find Pixels. Light 1, size small, colour purple, effect glow, position top left. Light 2, size medium, colour blue, brightness 100, position centre. Pixels lit up again.
Whoa, Ava, they look like planets.
Ava's tummy rumbled, and kind of like cakes too. And that gave her an excellent idea. Ava wasn't going to let Max decide how her game ended. She deleted the game over message and got to work building a shiny new level in its place.
Cake Galaxy.
Ava and Pixels coded and giggled all through the night until they'd built the most deliciously sciencey Cake Galaxy level ever. Pixels even got so used to being in the dark that he stopped being so scared of everything and started to turn into things that he was excited about instead, like spaceships,
Yay!
rainbows,
Wow!
and spotty socks.
Woo!
The finished Cake Galaxy level was so much fun that everyone wanted to play. Even Max Haxelot's magical pirate unicorn. And that's the end.
Thanks, Jess and Gav. That was fantastic. Anyone else want to visit Cake Galaxy? I sure do. I don't know about you, but I'm actually kind of hungry now. I need to learn how to code up my own donuts. Okay, so now we are going to get a chance to do some of your own coding. Our code master, Daniel, is going to lead us in an activity to help us save Ava in Codeland. Are you ready? All right, take it away, Daniel.
Oh my goodness, it's time. This is going to be exciting. So, first of all, I have to say a massive big thank you to Jess and Gav for that incredible reading of that book. How glorious. I think I learned something new this time. And I've heard them read it 3 times, and I've read it myself 2 or 3 times. So just imagine how many more times you guys could read it too. Today, we're going to learn how to code Ava. We're going to help her to code her Cake Galaxy. We're going to avoid a whole bunch of Max Haxelots. We're going to do some cool stuff. We're going to learn about code blocks. It's going to be epic. But before I begin with the code, I want to ask you some questions. So, it's a big question, this one. Do you recall these things that we were talking about earlier? You can see I've already cut mine out. Oh, look at that. Daniel's already cut his out. Have you? And if you haven't, guess what? Guess what? That's what parents are for. They can help you to cut them out now while you listen to the introduction to the code blocks and the other things. So if you haven't got enough of them cut out, you don't need all of them cut out. Just say 5 or 6 of them of each of the different ones that you have on your sheets. Then you'll have enough to get started very easily. And don't worry if you haven't got them right now, or if your parents have decided that they'd rather not cut, they want to focus and learn themselves. That's okay. Your parents are also allowed to learn how to code. They shouldn't be afraid of coding either. So that's fine. You can always do this later. But for now, let's kick off. Let's switch over to my other camera. Check it out. Oh my goodness, Daniel, you've already done it. How did you do it? Oh, I spent all day doing it today. It was very exciting. Oh, wow. I see that somebody's dad did most of the cutting out. Well done. Very impressive dadding. I'm proud of you dads out there, and also kids, but also dads. And also moms and also dads. Anywho, what happens here now is we've got on my sheet, on my camera view that you can see I've cut out all of these little code blocks and some of these little guys over here, which are Ava, our cupcake, and our keyboard, and different sizes of them. And you'll even see I got a couple of Max Haxelots, which we'll talk a little bit more about later. And on this is our Cake Galaxy that we're going to code into. So we're going to talk a little bit about that in a second. But before we do, I can see all of you have already been starting to use the Zoom chat window. So I don't even have to ask you to start using the Zoom chat. But what I will do is try to get everybody to respond to something, which is a test, of course. When you have a look at this Cake Galaxy, you'll see that there's rows of blocks, and you'll see that there's columns of blocks. And you can also see that the rows have got a 1, 2, 3, 4, and the columns have got an A, B, C, D. So the challenge, ladies and gentlemen, is, can you please tell me what row and column the keyboard is in? Go, 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 go. Of course, chat into the Zoom chat, please, with your answers. Oh, 1, yes, I see it. There's 1 correct, 2 correct, 3 correct, 4 correct, 5 correct, 6 correct. Oh my goodness, there's so many correct answers. And don't worry if you didn't get it right. There's no challenge here because, you know what, everybody got it right. I don't know what I'm talking about. Man, there are so many answers here. I don't know how to give you all a prize. I guess I'll just give you all the multi-thumbs up. Multi-thumb? Multi-thumb. Okay, multi-thumb off. What happens now? Let's go back to me. Hi. It's me again, multi-thumb guy. So let me tell you a little bit about the different code blocks. This thing over here, this is our go forward one place block. This is our turn left block. This is our turn right block. This is our send code block. And then this is our loop block. I'll tell you about this one later as well. Let's go back to this camera view. And the beginning of our coding experience, we see the cupcake, we see the max hexalots all over the cake galaxy, and we see the keyboard. Now, the challenge that we have to somehow help Ava with is we need to get Ava to her keyboard in order for her to be able to fix the cupcake, the cake galaxy. So that's what we're going to do with our code blocks. And the way we're going to do that is by saying, hey, you know what? I'd like you to move forward one position. And you know what this would do? Let's move that over there. When I say forward, and then I use this very important code block over here called the send code block, as soon as I put this there, that's when Ava receives the code and she says, okay, I'm gonna move first step forward. And then that's the end of my code. So did she make it there? Nope. Guess what? We're gonna have to start again. So we start again, she goes back to the start, and we know that we know how to move her forward now, but check this cool thing out. I'm going to do something crazy. I'm going to get her to turn completely around. What do you think is going to happen? Any guesses? I'm going to wait for some typing. I can feel some typing is happening into the chat. What's she going to do? Which direction is she going to be facing when I send this code to her? Exactly, correct. She will, when we send this code to her, she will turn once to the right, twice to the right, 3 times to the right, 4 times to the right. She's gone straight again. My goodness, she's moving forward instead of to the right, to the bottom, and to the left. She is managing to do a full 360 turn. That's kind of cool if you want to do a trick move. Now we know that that's possible as well. Next, we're going to do, the first thing we're going to do now that we understand all that, is we're going to figure out what she needs to do to get to the keyboard. So I'm going to start by saying, I think she needs to go forward 1. She needs to turn once to the left. Oopsie, that's twice. She needs to go forward once. She needs to turn once to the right. She needs to go once forward, twice forward. She needs to go to the right. She needs to go forward one more time, and I bet you that's right. So, do you think this is going to work? Give me a thumbs up if you think so. Oh, I get some thumbs ups. You know what? I hate to tell you this, but there's actually something wrong with this code. Can anybody guess what's wrong with this code? What's missing? What's missing? Yes, correct. Oh, well done. I see it. Whole lot of you've all figured it out. The send code is missing. Big hand clap from me. Codemaster Dan is clearly not such a good master after all, because he forgot to send the code. Don't worry, you don't have to be a master to send code. Let's go. 1 forward, turn left once, go forward once, turn right. Go forward, turn right again, go forward. Yes, she made it! I'm so happy for Ava. I'm gonna get a high five from Ava. Check this out. 1, 2, 3. Oh, I have to lift her up. There you go. And we go. Great stuff. Thank you, Ava, for my high five. Very pleased. Let's move on to the more complicated things. So that was fun, but obviously it's very easy to do something on that small scale. Now, if you so choose, you can, if you want to, if you thought that was difficult, but not too difficult, you could use this one, which is a make your own Cake Galaxy challenge, which is where you will put it down into your coding, onto your table where you're going to do your coding. Let's get the focus back. There we go. And you would place all of your max haxalots all over your galaxy. And then you choose where you want your keyboard to go. And you choose where you want your cupcake to go. And then you can write your own code. Oopsie daisy. Let's get the, come on, focus. Come on, focus. There we go. And then you can choose where to put, where you want to put all your different, your start point and your end point. And then you can make it more difficult for Ava to get around. But before we do any of that, because we already know that this was possible, we're going to go up one level. Level up 1, complete. Level 2, on its way. Hi, level 2. How are you? Oh, I'm good. Thanks. How are you? I'm great. Check it out. Level 2 is ready. Now, level 2 is genuinely a little bit more complicated, isn't it? It's got quite a few more blocks. I can see, let's see, I've got 1, 2, 3, 4, 5, 6 rows this time. There were 4 rows before, and there's 6 columns, which means that there are 2 extra rows and 2 extra columns. It is definitely a bigger field to program into. So what have we got here? We know, I'm going to just reorganize my coding environment. We can't have too much of a messy coding environment. We want to see where everything goes. There we go. Let's get all our Avas. Yeah, it's next in the right place. There he is. Perfect, perfect, excellent. Voila, good to go. So we now have Ava's ready to go on the cupcake. Excellent. So on this one, it's interesting. We now have a different, the cool thing about coding is that there's often different paths that you can take in order to get from one place to another, in order to succeed in whatever the challenge is that you've set yourself. So what we can see here is we could go this way. We could also go that way. We could also decide that we want to go on a different journey completely, just because we like to go on an exploration adventure. My goodness, but that's what we would call an inefficient journey. It means that we're spending a little bit more time than we probably need to in order to get to the right place. So what we'll start off with this time is we're going to try and just make it real simple. We're going to do the simplest effort to get to the keyboard, and then we're going to make it a little bit more complicated. It's going to be very fun. So the first thing we need to do is Cupcake is facing that way, so that's the way that Ava is facing. The first code piece we need to do first is dun, 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 turn to the right. So she's going to turn to the right. She's going to move forward once and then twice. She's going to turn to the left once. And then this is where things get crazy exciting. She's going to go forward once, twice. Let's see, she should be, that's 1 forward, 2 forward, 3 forward, 4 forwards she needs to go. Okay, so let's go once, twice, 3 times, 4 times. Then she gets to turn to the right. She needs to go forward 1 more time. And is this going to work? Is this ready to go? Is this anything wrong with this code? You already know what's wrong with this code. I can't trick you guys with that one again. So I'm going to go straight for the send code block, and I bet you, let's see if this is going to work. Turn to the right. Go forward once, twice. Turn to the left. Go forward once, twice, 3 times, 4 times. Turn to the right. Go forward. She made it to the keyboard. Excellent work. However, I see something happened 4 times in a row here. That's pretty cool. I see that some of you took a different route. There's nothing wrong with that at all. You can take whatever route you want. That was exactly what the point of this particular exercise is all about, is discovering different routes. But let me tell you something else that's cool to discover. We had 1, 2, 3, 4 forward movements, 4 forward code blocks. Remember this crazy looking code block over here? This is our repeat code block. It's our loop. So I'm going to stick our loop in there, take out all of our 4 forward arrows, put the forward arrow into the loop. I'm going to write into this. Ooh, I love these pens. I can change its color. What do you guys think? Blue, green, red, black? Any thoughts? Oh, let's see. Whoever says something first, I'll choose that color. Green. Okay, green it is. Good choice, good choice. I was already there. 4. Perfect. Did I just take some? There we go. Perfect. So let's see what happens. Let's bring her back to the start, send the code, turn right, go forward once, twice, turn to the left, go repeat 4 times. 1 forward, 2 forward, 3 forward, 4 forward. Excellent. Turn to the right, go forward, and she made it. It's amazing. So we did it, guys and gals. We made it. We got to the keyboard. But even that may be a little too easy. So shall we make it more difficult? What do you guys think? Thumbs up if you want it more difficult. I got one thumb up at least. Okay, I see more than one. Okay, we're making it more difficult. How are we going to do that? Let's see. I think we're going to do this. We are going to add a keyboard right over here. That means that Ava has to get to keyboard number 1, which is over here, and then she has to reverse, come back, and get to the next keyboard. Okay, that is going to be exciting. So the first thing she has to do is turn around, take away that. I know that this code gets her to there. Perfect. We have successfully got her to one of the keyboards she needed to get to. We don't have to change anything about this code because we know it works. We've checked it. We've confirmed that she makes it there without any trouble. That's good. So now all we have to do is figure out the rest of the journey. And so what we'll do is we can either turn to the left or turn to the right. I mean, I don't mind. I see that we've only got 2 right turns on here and 1 left turn already. So I'm just going to use 2 to the lefts. Left turn number 1, left turn number 2. She then has to go forward once. Then she has to turn again to the left. And then she has to go forward one more time. Oh, guys, what's happened now? We've got to the end of our space. What happens? Can she be coded? Of course she can. We just got to move it up a little bit more. No problem. The good thing about this code is that it actually goes on forever after the sheet ends. You don't have to worry about only having this much space. Code can take up as much space as you want. Obviously, when you get better at coding, you try to find the simplest way to write things, and then you might actually make it shorter. So later, we can make this whole code piece much shorter if we want to find ways to do that. Oh, I see somebody's already done it. Well done. And don't worry, it's not that difficult when you give it a shot. So let's see. We have now turned around, gone forward, turned to the left, gone forward. She has to go forward one more time. Can you still see that I'm on the bottom there? Yes, you can. Go forward one more time. She then has to turn. She's facing that way. I have to think about this. She's over here, I think. So she has to turn to her left. Right? So she's basically gone left. She was here. She's gone left, 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 and left. Wow, she's going to end up doing a full 360 in left turns. Can you believe it? That's kind of cool. Left, she has to go forward one more time, 2 more times, and then she's going to go into the right, and then she is going to go forward 1, 2, 3 times. I'm going to use another loop. I've already pre-written this one. Here it is, another loop to go forward 3 times, send the code. Let's see what happens. This is quite the epic code that we've written here, guys and gals. Let's do it. So from the beginning, let's go. She goes to the right, forward, forward, to the left. 1, 2, 3, 4 in the loop. Turn to the right, forward 1. She made it. Turn around to the left once, to the left twice. Forward to the left again. Forward to the left. Oh, forward, sorry. Forward, forward. Then to the left again. Forward, forward to the right. And then she loops. 1, 2, 3. She made it. 2 keyboards. Oh my goodness me. That was an epic piece of code. Now, oopsie daisy. There I am. Oh, whew. You may see I'm sweating a little bit from that. It was quite intense, but not so intense. It was actually it was more fun than intense. So what have we figured out? Coding has got different ways of working. You don't have to do one way only. There are other ways to do the same thing. Ultimately, if you get to whatever the outcome you're trying to achieve at the end of your code, well done. You can always revisit it and make it better. You can also find other ways to do it. There's nothing wrong with any of that. That's the cool thing about coding. It's all about figuring things out and discovering for yourself if something's right or wrong. And if it's wrong, what other ways could you think about doing it? Then the best part about it is just when you think you've done it right and you're happy with it, you then decide, you know what? I think that's good, but I bet you I can make it better. And that's when you start to challenge yourself. And that's what we did here today. We said, hey, one keyboard being found by Ava inside of a cake galaxy to save the galaxy from Max Haxalot, that seems like a fun challenge. But wouldn't it be even more fun if we add even more keyboards to the challenge to make it much more hard for you? Hey, I see that somebody's dad does JavaScript. Well, I hope you also do JavaScript. So I think that's me. I think it would be great if you have any questions. And I'm going to hand it back over to Ben and Andrea to find out what questions there are.
Woohoo, all right. Well, thank you, Codemaster Dino. That was truly awesome. You know, learning to code is super cool. A lot to do with it. Awesome. Thank you. So as Daniel said, we are now going to open it to all of you and give you the chance to ask some questions to authors Jess and Gav, and also to Codemaster Daniel. So if you have any questions about the book or coding or anything like that, please type them in the chat now and we'll answer them as they come in through. All right? So go ahead and start posting your questions right now, and then we'll take them as they come in.
I see somebody's got the dream to make video games. Can I just say, I think that's such a great dream and definitely a great thing to explore and do, because let me tell you something cool about video games. Video games aren't just about coding. Coding is just a way to make them real. You also have to think about what you want your game to look like. You have to think about how the game is going to be structured so that it's fun to play. You also have to create all sorts of really interesting things that make it more challenging for people, make levels harder, make levels easier. It is such a fun and interesting world in the world of game development. So great dream.
Looks like we have a question here for Jess and Gav. So how did you come up with the idea for the book?
Oh, hi, that's come from Shelley. Hi, Shelley. I think Shelley won a copy of the book from your competition as well. So thank you for that question. So I didn't learn to code when I was at school, and I really wish I had, because I think when you can code, you really can make your ideas happen. And when you're young, I'm sure you have brilliant ideas every day. And I think if you learn to code, you can bring them to life and actually change the world just like Ava does. So if you want 1,000 cupcakes, you should have 1,000 cupcakes. And you'll get that if you learn to code.
Yeah, I think we wanted to show that coding's not that scary or big or hard. It's just quite simple ideas. And once you get your head around it, you can just make it happen.
Excellent. Cool. Looks like we have a question for Codemaster Daniel. What is JavaScript?
Great question. So JavaScript. Oh, it's an interesting question. Oh my goodness, how deep should we go? I don't know if we should go super deep. What we should think about is this. You know the internet, like the whole internet. Okay, most of the internet. There's a lot of it out there, right? What's really interesting about the internet is that over the last 20 years, slowly but surely, more and more technology has been used to make it more fun to use, right? Because in the beginning, believe me, it didn't look nearly as cool as it does now. In fact, all this video stuff we're doing right now wasn't possible back then. So back in the day, they were using some programming languages to make the internet look cool or work properly, etc. JavaScript is actually today's version of that. It is a way that web pages are programmed in order to display and do really interesting things for you in your browser window, even in a lot of the apps that you use on your iPads, on your Android devices, etc. So it's a scripting language rather than a programming language, and that's where things get a little bit more complicated. But the important thing to note is that when you tell something to happen in JavaScript, best way to see it happen is typically inside of your browser window. And it's very easy to even edit what you see in your current browser window using all these online JavaScript editors. That is a very long, complicated answer, I know. But the most important thing is it's the programming language of the internet these days.
We've got a bunch of other questions here. Here's an interesting one. At school, we use Scratch. What code should I try to learn next? Any recommendations there?
Ooh, that's fun. I'm gonna suggest one, and I bet you Jess and Gavin may also have some suggestions. But Scratch is a really great way to learn programming concepts, like the broad concepts of programming. You know, how do you move things around a screen? Also, how do you what does a loop do? How do you create a condition statement? Like if something happens, then something else can happen. That's a really great environment to learn. My son learns with Scratch as well. The next thing from Scratch that I think might be interesting to play with, Python is a really good language to learn because it's quite straightforward in the way that it's written. And there's a lot of really great stuff you can do with it. One of the things that we've done a lot of work with at Tech Will Save Us, and a lot of our products actually use inside of them, is something called the microbit, which is a little electronic thing that that you can actually program LEDs on it, lights to turn on and off. It has Bluetooth on it. There's lots of cool things on it. But the important thing is you can actually program it directly using Python. So you could either program it with Blockly or with Scratch. And then when you're done with that and you're bored of that, you can then go straight into Python. You also don't have to do hardware that way. You could do it straight in the browser. There's loads of great examples of how to learn Python online. Gavin and Jess, do you guys agree, or do you have any other recommendations?
Not specific code types. I mean, it depends on your age and what you want to do. I always think that, you know, really good coders don't really just pick one thing and get stuck to it. So I would think about what you want to make, if it's a game or if it's a website or if it's a toy, and then kind of look into, you know, which code's going to help you achieve what it is you want to do. We always say it's, am I still here? Sorry, I got a message. Yeah. We always say it's really good to start with the toys. If you're young or if you're a parent and you're looking for something to get your kids into it early. I mean, we wrote the book to just try and get code kind of normalized in people's minds so it doesn't feel like this big scary thing. And I think playing with toys and things like the Tech Will Save Us kits are a really good way for littler kids to kind of get their hands on, get involved and learn the concepts of coding. And to be honest, by the time they've done that, they'll probably know how to look it up and find out what they want to do next themselves.
Cool. We've got a lot of great questions here, and we're going to try to get to a couple more of them. We won't probably be able to get to all of them, but I'll call out a few others. Here's a great question for everybody here. When do you use coding in daily life? Some examples of when we might encounter coding and might need to use it in our daily life?
That's a really interesting question. Let me think about that. Because I mean, it's a challenging question for me because obviously I use code in the work that we do at Tech Will Save Us. And it's a part of what we create at Tech Will Save Us. So in my everyday life, it's a part of my job to play with code and to test things and to find different ways to code things, etc. But I'll give you a great example of one that I use when I'm not typically playing games or making video games or playing the products with the products we've created. I don't know whether some of you have seen Spreadsheets. Your parents might play with Spreadsheets a lot. They're very boring, and I don't recommend anyone to play with them unless you absolutely have to. But in Spreadsheets, you have it's basically just a lot of mathematics. And it's ways to kind of connect things together and understand systems and the way systems work for businesses and for other things. But you use code, you actually use clever formulas inside of there, which is kind of like programming, in order to make your system work better. And that isn't overly, I know it's a very convoluted answer. The short version is, if you want to write a really interesting mathematical question, create a very interesting mathematical formula inside of your spreadsheet, you can easily, and it's kind of like coding. And a lot of people who are in the finance industry do that all the time. That was a long one. I'm so sorry, guys. Any other great examples of coding in the real world? Because I'm the wrong person to ask, because I always use it.
We'll keep thinking about that. And I'm going to kind of combine two other questions into one. And this is for Jessica.
I'm going to pause you. Sorry, I'm just thinking about one thing I will say is you encounter coding all the time in the real life. So for example, you know, when you go to, when you're driving in a car and you stop at a traffic light, right? Something is telling the traffic light, hey, traffic light, you got to be red now, because those ones over there are going to be green, and those ones over there are going to be orange. And if you're not, then the whole system collapses, because we'll have cars driving into each other, which we don't want. But that is a system that has been devised by people and probably programmed in order for it to work brilliantly for all of us who get to use it every day. So that's a great example of seeing coding, encountering coding in the real world. And one more great quick example is, you know, when you go to the loo or the toilet, and you know, when you go and you see there's a sink with like a little faucet there, and you put your hands underneath the faucet and the water starts shooting down without you having to touch anything. Well, there's a little sensor in there that's programmed to say, hey, when you see something in front of you, turn on the tap. So that's a little bit of really simple coding, but it's a good example of things that you might encounter every day.
That's great examples. Yeah, thanks. All right, so this is kind of a two-part question for Jess and Gav. First one was there any special significance to the numbers in the top or the corners of the pages? And then second part, was it hard to turn coding into a story?
I think the numbers, I'd like to say something really clever. I think it's actually more Lyra who did the illustrations, put them in to make it feel more like a game, so there's a score going on. But in terms of ideas for the stories, we actually had too many ideas. So it wasn't hard. Because with coding, you can do so much. We wanted to show that. So we had to really take things out. Otherwise, we'd just have a very long book. We may have some more books in the future. It'd be great. But yeah, coming up with ideas around making a story out of coding was quite straightforward, really, because it's everywhere and you can use it in any way.
Yeah, I think once we came up with the idea that she lived in a computer game, it was pretty easy, because obviously computer games are all made from code. So it suddenly meant that everything around her, she could just change, make bigger or make smaller or different color. But that also meant that Max could do the same. So once we kind of had that idea, it was just, what's the worst this little boy can do, that gave us ideas.
We've had a couple of questions. People want to know, what's everybody's favorite video games? Anybody have any favorites?
Well, can I suggest that everybody who's watching this right now should write their favorites into the chat stream, because I'm really interested to know what your favorite video games are.
That's a good point, yeah.
I will say that I have been a fan of a game called Civilization from when I was probably 12 or 13. I can't even remember. It was such a long time ago, many years ago, before Minecraft existed. But Civilization is a really cool game because you kind of learned a little bit about history and how different civilizations grew up around the world. And of course, you learned how to battle one another, which isn't good and bad, but you could also learn how to build culture. You could also learn how to take care of your cities with all the people living inside them. I love that game, and I've been playing it ever since for many years.
I've got a Switch, so I play a lot of Mario. I like Mario Party because you can play with all your friends. It's just a really good group game. I like Animal Crossing because it's very relaxing. And I see a lot of people saying Roblox. I sometimes play Roblox, which isn't relaxing, but kind of hard to stop sometimes.
I think,
What about you, Gav?
Minecraft, Roblox are great, but my favourite game at the moment is a game called Untitled Goose Game, where you play a naughty goose, and me and my son play it for hours. It's brilliant.
You know, there's also some amazing board games out there, which I highly recommend looking at, because especially if you're interested in programming video games, you know, there's a concept of video game development called game mechanics. You know, how does a game actually work? It's not just about having, you know, different player names and having a scoring system. there's got to be things that make the game interesting for people to want to keep on playing. How it gets more difficult, how fast it gets difficult, all that sort of thing. What's interesting about board games is that that is all has to work with rules. Board games work only with a really simple thing. They give you a set of rules, they give you a simple, of course, a thing to play on, a mat or whatever it is, a board, a couple of little pieces, a couple of dice, but the rules are what make it super interesting and super fun to play. And that is what I highly recommend you guys start playing with your folks and with your families, because it also shows you how other people play the game with you. And so that's a really great way to learn about the behaviors of people when they play games. And then you can also think about how that relates to when you play video games. Plus, it's also nice to not always look at a screen when you're playing games. Games off screen are also cool.
All right. I think we have time for one more question. And I apologize if I miss anybody's questions, but this is a great one to finish up with. What should I do to become a good game maker? Any advice for aspiring game designers?
I would just say do what you love in terms of like the concept. Think of like what you love doing. Whenever you're working on something and you enjoy it, then chances are people playing it are going to love it too. The great thing about code is that there's no like real rules. So just let you know if you want 1,000 cupcakes or there's no kind of limit. I would take all your favorite things, put them together, make sure you know there's a way to die or lose, and see what you come up with.
You want to add anything, Gav?
I just agree with Jess. Yeah, just find something you're passionate about and keep going at it. Just
Cool. I mean, I have nothing else to add to that. That was a great recommendation. And I still go back to what I said a moment ago. Play lots of different games as well, so that you can discover what games you love to play. Why you love to play them is the key thing to remember, because that's what that kind of enjoyment, that love, that fun is what you want to make sure that other people can experience when they play the thing that you've invented. So that's definitely something I would suggest.
All right, well done.
I do see somebody asking about favorite board games. Oh my God, so many. Let's see. A really cool one that we started playing with my son about a year ago is called Mechanica. It is, I would suggest looking it up. Mechanica is really cool because you basically have to produce robots and sell them. And it's like there's a whole like machine part of it. It's a really cool, it's fun game. But then of course there's the other obvious ones like the card games that everybody likes to play, etc. And card games you can travel with, which is why we have them with us today.
Excellent. All right. Well, thank you, everybody. I hope you enjoyed the workshop today, and hopefully maybe even learned something new. You know, we sure had a great time with you guys. Before we go, just a few quick things. First, please tell your parents that we'll be sending out a survey to everybody. We'd really appreciate everybody's feedback on the workshop today, because this will help us to make our next workshop even better. This was our first time at it, so hope you enjoyed it. And then also, if you like the book and want to get your own copy of Ava In Codeland, you can certainly check it out on Amazon. And there'll also be some links to purchase the book in some of our follow-up emails as well. And if you like the coding activity, or if you want to learn more about coding or designing your own games, be sure to check out, we've got a free club called the Games Designer Club. It's on our website called techwillsaveus.com, and it's got all sorts of great projects and activities where you can learn to create your own games. Just everything we've been talking about. So again, it's on our website at techwillsaveus.com. And then lastly, we're going to be posting a recording of today's workshop on our website. So if you want to watch it again, relive it, or if you want to share it with some of your friends, you can find it. It will be posted on our website probably in the next day or two at techwillsaveus.com. We'll be sending out links to it as well with some follow-up emails. So thank you again for joining us today. We had a great time. I hope you did as well. And hopefully you're inspired to create your own galaxy, just like Ava did. So with that said, everybody's just going to give a thank you and a wave. And thanks again for joining us. Hope you had a good time.
Bye. Thank you.
Thank you, everyone.
Thank you so much for coming.
All right. Thanks, everyone. Take care. Thanks for joining. Bye now.